Hello, everybody. Welcome to this Arduboy Dev stream. Um, quite happy to be with you today after a while. I'm sorry I was quite busy these days. So last time we started to implement the change of the screen, or we refactor the position, the coordinate system of the main character for the main character to be able to be played in different screen. And then we started to implement the change of the screen. We already had the camera transition that we implemented almost at the beginning of the development. We started by that, but now we are trying to connect this transition with the actual character move. And last time I left you was it was almost the end of the stream when we tried to do that. So I just quickly did some code, but knowing that it was not really working, and I left you saying, okay, I will have to think about it. So yeah, I think I figured it out, but I didn't went too far. We will continue together. I think I managed to make it work on one axis. And you will see there is some bugs that we may fix today probably. So I just wanted to summarize you what we are trying to achieve. So I made a small drawing. Sorry for the for the drawing. I still have some difficulty to draw vertical lines with my pen. I'm really not an artist. Although I think I'm improving. Like the middle one is quite straight. All right, so yeah, basically here what I've done is full screen, right? So how to say that? Everywhere I write screen in green, and then I write the coordinate of the screen. You can see it like the coordinate of the screen. Like in the top left corner, we have the first screen, which is maybe coordinate 0, 0. That's the first puzzle screen. But not necessary in the final game. We can start on any screen, but that's the top left corner of the screen. On that screen, there is a certain number of sprites horizontally and vertically, and we have two constant value for that. So we have the number horizontal sprite per screen, which is 16. I show you again. They are just here at the top of the map manager. We have the horizontal sprites per screen 16 and the vertical, which is 8. So these are the two number here. So what I've drawn in black is here these are the lines. These are each little square is one sprite basically. All right, so we have 8 sprite here. So of course I didn't draw all the line, but to try it in black. Yeah, you should have 8 sprite vertically and 16 here horizontally. All right, and this amount of sprite 16 by 8 will make one screen. So the next screen is just behind that. All right, so in red here I've written the coordinate of what I call the camera X and camera Y. So here obviously that's the 0, 0, and then just under that's 0 and 8 because there is 8 sprite per screen. So the camera Y will be 0 here, 0, 8, and here we are at 16, 0 or 16, 8 for that screen, right? So we will always display the game screen by screen. So we have one screen, then we move to the next screen, then up or down. We never draw in between screen except during transition, of course. So when the camera is transitioning, we are drawing in the middle, but then when the camera finish the transition, the player always play in one screen. Okay, so also you can think about I can call it also a screen puzzle. So basically you have one puzzle per screen, right? So the game is, you as a player, the player try to escape one screen and then move to the next screen, and he has a new puzzle to find, so to solve. So the player solve the puzzle to escape that screen to wherever is the exit. Okay, so for example, I can say here the exit may be here, around here, and then after that maybe it has to go up here, or maybe another screen can be the exit can be here to go down, etc., or go up. So it really depends after that how you lay out all the screen puzzle together as the global map of the game, basically. And when the player goes through all the screen, then he just exit the game. He just win the game, win the map, or win the level. I don't know how you want to call it. All right, so here for the, if you remember, but that's the one of the early stream, we have the camera transition X, Y, and the target. So let me show you again. So this is just this variable, right? The camera X and also the target X and Y. And basically during the transition, this value can be in between, like I said. Well, usually we just transition from one direction. We never transition in diagonal. We could, the code could manage it, but it's not intended. The game will never present that situation, so we will always transition horizontally or vertically, up and down or left and right, never in diagonal. But anyway, so during the transition, camera X and Y can be in between, but when the transition is finished, basically the camera transition has to be one of these corner, right? That's the fixed corner. So, and the target also. So has to be 0, 0 or 0, 8 or 16, 0, 16, 8, a multiple of 16 and multiple of 8. Basically a multiple of these two constant value, right? All right, so that's how I had to implement this. So if you remember, we are in the update of the map manager, and I left you during the last sprint saying that we should look at the coordinate of the player and to see if he's exiting the screen, and then if yes, we should change the target. So basically that's what we should do, but of course my calculation was totally wrong because I just did it quickly. So basically I'm starting from so basically now I'm computing the screen puzzle, what I call the screen puzzle X and Y, and this variable is one of these red target one. Okay, so that's why I call it the screen puzzle, because it's not the current one, but the final one, the one I want to have. All right, so and basically the current screen puzzle is basically equal to the camera Y if it's not moving, but if it's moving, I just want to be to get the corner, right? So let's say here, for example, if let me draw, take another color. So let me say, for example, if the current screen is transitioning like this, okay, that's the screen at during the transition, right? But my current screen is still this corner here. I still want to have this corner here, even if the target, not the target, but the camera, the current camera Y is here, X, sorry, is here, but my screen puzzle should still be here. and then I will switch to the screen puzzle here. So basically I just want to have that here. So how to get that? That's quite simple. We take the camera X here, and then we divide it by the number of sprite per screen, and then we multiply it by the same value. So you just have, it's like you round it to that number. For example, if you want to be here, right? Imagine you are transitioning. Let's do another color again. Let's do it to, okay, this one. Imagine you are transitioning like this. Okay, so your camera X will be like, I don't know, like 18, 19, something like that. Okay, you divide it by 16, you get 1 point, blah, 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 something. And then you want just to multiply again by 16 to exactly have 16. So 1 point something, okay, if you have a float number, but if you have an int number, so this all this decimal will be clamped, right? Would be removed. So 19 divided by 16 as a number, as a integer operation will be 1, sorry, and you multiply again by 16 to get 16, which is the red corner you want here, right? But basically what you are doing here, and I'm doing a little trick here, is that this you are just masking some of the low bit. It's the equivalent of this operation divided by the screen multiplied by this. It's equivalent. Why? Because this one equal 8, right? Or is a multiple of is a power of 2. If it's not a power of 2, of course it's not equal. But because it's a power of 2, then you can just mask this one, right? So this value is, let me get the calculatrice. Okay, here. Let me put it here. All right. Program, okay, in decimal. So FF8, of course. You can see the bit here that just masking the 3 last bit, right? And you take the rest of it, and because of course 8 is just yeah, it's just that, of course. So basically dividing by 8 is also the equivalent of shifting 3 times to the right, and multiplying by 8 you shift back to the left. So it's basically you shift back to the right, then shift back to the left again, just to, or you just mask, you just don't want the last bit, right? So it's just a little trick, but yeah, we can do it. If you are not comfortable with it, you could just write this this operation. You can just write it if you are not comfortable with, but just to be more optimized, you can just do it like this. Of course, if we change this value, then like at the beginning it was equal to 9, then it will have bring some problem. We reduce it to 8 to display the bar, the score bar at the top, sorry, and that's quite convenient. And we can also do the same for the X because it's 16. So this time we will mask by FFF0 because we want to discard 4 bit. And you may think, oh, that's very lucky. We are very lucky to do it like that. Actually, not that much, because the screen is also a multiple. The frame buffer is also a multiple of 2, a power of 2. Sorry. So so that's a bit normal, and we get this kind. And also because our sprite is 8-bit sorry, 8 pixel wide or tall. So everything actually, because everything is yeah, powerful to just everything falls back in place nicely. All right, so basically, so I get the screen puzzle Y from the current camera Y. Even during transition, I still get the corner, a stable corner. And then I'm checking if Rick, if the Y of Rick is less, so that means it's going up, or if it's more. So if it's going up, like maybe using a ladder to climb above, and of course this Y is a real pixel coordinate, right? It's not sprite coordinate. So of course I should multiply by the sprite height, which is 8, we know that. All right, so if it's less than that, then the new target is equal to the puzzle minus the number of sprite per screen, right? And this is so that's for going up, and for going down is the same. The next screen puzzle is the current screen puzzle plus 8, right? And we check if the current Y is greater than the next screen puzzle, and then we can move the target camera to the next screen puzzle Y. Right, so let's try that, and you will see there is some kind of bug. I can try to do it in full screen. All right. Oh, I've tuned my camera settings. Sorry, that's maybe okay. And then you can see that we are trying to draw the memory after that. So. All right, so the problem here, the bug we have here, is that when we are falling, when the main character is falling, and we are also transitioning the camera, then the decor is also moving up. So basically, the character is moving down, and the ground is moving up, right? So basically, in one frame, the character has moved more pixel than what is normally moving when falling, right? And so we miss the collision, so we didn't detect the floor. So there is different way to deal with that issue. The first one is to freeze the main character during transition, and some game does that. Maybe you know it. So when the camera is transitioning, the main character stop moving or stop falling, and then when transition is finished, the character continue to fall. So that's the first possibility. Or we can try to also add the movement of the transition when we check the floor. So I think it's basically inside the rig and inside the collision. It's probably here. It's the static collision, and if we are falling, which is around here, I think. We just check some collision under here, and I think that should be probably changed to get go even higher to find the proper collision. So we can see that later, the way we deal it. Right now, I think I want to first implement the same logic for the X, and see if we can transition smoothly horizontally. So okay, first I check the can check the X or Y, doesn't matter. I think it will probably have the same probabilities for transitioning. So here then we can, after we can just check the X. So screen pulse X is camera X minus FF0, so it's same as horizontal sprite, so X and the horizontal sprite per screen. All right, and I should do the same. So basically, yeah. Also, basically, I want to say for the for going up is not exactly correct. I think here the Y, get Y of the character is the top corner of the character. So I don't want, if I jump, if my character is just here and I jump above, I don't want to immediately change the screen. I only want to change the screen when the fit disappear, goes out of the screen, right? So here it should not be just get Y, but get Y plus the fit. But we'll probably add a function to do that, because well, the map manager doesn't know where is the fit, so I should ask Rick where is the fit. But that's fine, and we will have probably the same logic also when going on one side and on the other side. So on the left is just yeah, it's just Y and X, sorry, and on the right it should be no, that's the opposite. On the left it should be X plus the width of the characters to have his right side, and on the right it's only X. So sorry, I think I need to, sorry about that. So let's try that for now. Going on left, okay. Then target camera X equal screen puzzle X minus number horizontal screen per screen, horizontal sprite per screen. Otherwise, can do the same. It's very similar code. Huh? Okay. So the next screen X, a current screen puzzle X plus and the horizontal screen, horizontal sprite per screen, and then X is greater than the next screen puzzle X. Oh yeah, it's not the sprite height, but the sprite width for sure, which is the same actually, so just to be correct. And here target camera X equal the next screen puzzle X. All right, so let's change the map. Oh, that's okay, I already put a hole here, but do I have, I'm not sure if I have enough if I have floor after that. So yeah, it's this line. Okay. Then I should add more, I think. Okay. I'm confused. Okay, never mind. Let's try like that. We'll see what is the level on the right. All right. Okay. Yeah, I4. But seems to work. So I think that's the ground here, the ground. Let's put more ground here, I think. All right, let's try that. All right. Ooh. Yes, but again, I'm going too fast. Yeah, I'm still in the collision. Okay. Don't know why I'm in the collision. Because I only translate to the right. Let's just remove one more block to go by walk instead of going by crawling. So that's should be that one. Let's remove that one too. Yeah, that one was the landing platform. Just remove that one. Nope, didn't change the. Oh yeah, this one, and it's on this line. Yeah. All right, like this. It's like it's strange. The characters go into later, it seems. Because it has the ladder state, the climb ladder state. Yeah, it has the climb later state. Okay. All right. So let's try to fix that problem. You know what? Before fixing it, I will try to actually maybe climb and jump. No, maybe not. Just check why enter into the later state. So I think it should be this one, check later collision. I think this one is checking if it's outside the screen. Okay, if it's outside, we should say no. Sorry, I will. Yeah, if we are on outside of the screen, we should not. 0 less than, okay, with I'm entering into the screen, the later. Let me check where. Forgot. In front of later, and we are date input. If I jump or fall, yeah, if I jump or fall in front of ladder, I just climb the ladder. All right, I may fall actually. I didn't press any down button, so it should not come from here, neither up button. So okay, I just enter into climb because I'm falling in front of a ladder. So there is maybe two bugs. First is why I'm falling, and the second one is why you think I'm in front of a ladder. That's two problem. Maybe we can check the fall first. State is not jump, so we are going that way. This I don't think so. So we are going that way. Is there collision at? Is there any collision at this one? Okay. Yeah, this is the bug. This is the problem. So if we are outside of the screen, I just return false. It's probably just a matter of one frame, I would say. Because this one, let's check again, get X X on screen. Okay, camera X, the first frame doesn't change, and the transition may be 0 the first frame, so yeah, it's just a matter of 1 frame or 2, I think. So there's different way of dealing with it, so maybe we can just, should we return false here or not? I'm not sure. True, I mean, instead of false. Other thing is I can also start transitioning 1 pixel before the character totally disappear or something like that, 1 or 2 pixels before. That would probably solve the issue. Okay, let's try with true right now. I think that has another side effect. So, yes, another side effect which I know is like you cannot fall down. Probably, you can walk on an empty screen if you do that. So that's maybe not good. But let's try like that, just to see if we can transitioning correctly. Seems I'm blocked. I cannot go down. I cannot go left also. It's just like I'm totally blocked. Strange. Alright, so probably not a good idea to do it like that. Let's try to transition a bit earlier. Okay. Mine. Just put equal maybe. Let's try that. Yes. All right. Works well with equal. Just let's do that. Let's do that. So we'll just add equal here also. Yeah. All right. So so now I'm thinking we should, like I said, because if I transition from that direction, you see that I'm actually transitioning before the full character disappear on the screen. So that's I don't want to do. So I will add some more function in Rick. So I will call it get right. Knowing that X will be left. Or should I rename get X by get left? I think it would be better to rename it, honestly. Yeah, I think I will rename it. So get left, get right, get top, get bottom. Function to get the pixel, not pixel, the coordinate of the sprite of the main character. So where did I put the get X? Here. So get bottom. This one plus. So this one is yeah, maybe a bit complicated. Depends if I'm crawling or not. I should probably write it somewhere else. Well, that's fine. So this one. So you see that's why it's more logical to add that function inside rig, because depending on the rig state, on its own state, it can adjust this can adjust the width of the sprite. It can give you the correct answer. And okay, and I think that's the same for the height, bottom. Yeah, I can just copy that, I guess. Height, or this one plus height. All right. So then I need to change that in the map manager. So if I'm less than the screen puzzle, I want to get the right. Oh, it's the height, sorry. If I'm going up, I need the bottom. All right, if I'm going down, I need the top. if I'm going left, I need the right, and if I'm going right, I need the left. All right, not sure it's compiling. Maybe I already have some get x get y somewhere. Yep. Here it's in which function? Arrow launcher. Okay. Arrow launcher. Top. All right. Yeah, we can fix it. You see here we have some kind of is inside the detection range. Okay. Not really actually, because I still want to have the arrow firing when even when Rick is scrolling, so that's fine. Can leave it like that. Oh, so that one won't, yeah, it's okay. Well, that will work. All right. Oh, I didn't save, sorry. Okay, let's try that. Okay, I'm in later state again. Okay. I'm entering into later state in between. All right, so what I propose you is to commit this first, and then we will fix the bug, because I think that's a first version, a reasonable good first version, I would say. Okay, I'm streaming 48 minutes. Okay, yeah, we still have some time. Okay, so okay, so what did we change? We rename x and y, get x, get y. Okay, we have changed the map for testing purpose. All right. The big change is the map manager. Okay, we changed the which screen we start. Then this, of course, that's the main code for changing the screen. And in Rick, we have our left, right, top, bottom, and the prototype of the function. So first implementation of Rick, changing the screen when going out of the screen. Set the screen puzzle. All right, let's commit that. And let's continue. So we had an issue on the a later collision. So I guess this one. Add Y on screen. Yep. Check pixel column. I guess we are in that function that give us something. No. Okay, it's false. It's false if we are out of the screen. Okay, for inside. Okay, otherwise it's false. So maybe it's that one that tells us that it's true. Middle x, get the x coordinates. Yep. It's the draw that should return true. Just want to test again. So again, it's when we are falling and in front of the ladder. So when we are falling, it's in that function, a collision at. Yeah, if it's out of the screen, it's false. The thing is, here I'm checking the X itself, right? And I should not, because I can still be considered on screen when I'm partially on screen. So or instead of adding +2 here, I should add it here, because I can still have the test the pixel on the Arduboy here. That would make more sense actually. Let's do that. Sorry, didn't show you the code. Here, I'm checking the Arduboy. Yeah, actually it's not correct. I'm adding +2 here, but actually I should add them here and test after that if it's on screen or not. So let's move that here, and this should move it here. And then I'm checking the pixel. Oh, but I'm checking this one also. So wait, I'm confused. Why I'm doing that? I'm checking x plus 2 or x. Why I'm just checking these 2 pixels? Plus 2, yes, it's the center, but why x only? That feels strange to me. I forgot what have done that. Let me check, where is this? Static collision. Here. Okay. That checking x and x plus 2 is the center of the main character. Just 1 second. I will open the sprite. Plus 2, okay, 1, 2, plus 2 is here actually. I just want to check the fit, yeah. But why not? Why not this one? I wanted to check these 2 actually, here and here. That's why I wanted to do that. Okay, so my test is not correct. I should call it left on screen and right on screen. Okay, and left should be plus 2 and right should be 2, 3, 4, 5, 6, 8. Yeah, 2, 3, 4, 5, 6, 8. Right, so I will tell left or right. If left or right have any collision, then yes, I have collision. But this test is now not correct. I should test left can be out of the screen if right is not, or right can be out of the screen if left is not. So it should be like this. If left and right are less than 0, or left and right is greater than width. Or this one. However, that may still not work because of the hat, but let's try that way. Oh, oh, oh! I break something. It's clearly not working. Yeah, I know. No, I forgot. Let's check the difference. Ah, yes. I check. That's a really strange check, actually. Here I check Y, and here I check. Oh yeah, I put +6 in the Y. Oh, I've done nothing. Ah, okay. It's like +2 +6. Okay, I'm just was not aligned. All right. I understand. So that's why it's good to always make a diff when you did something totally wrong. So no, this one is still a Y. Okay, and here I was checking +2 +6, but I think it's +2 +8, right? So now I understand. Before I was testing the left and the right, but I did +2 +6, and I think it's not +2 +6, it's +2 +2 +8. +2 +6 is like 0, 1, 2, 3, 4, 5, 6, right? 2, 3, 4, 5, 6. Here could be 7 then. 2, 3, 4, 5, 6, 7. Actually, it could be 7. Should be 7, not 6. All right, not 8. All right, so here is 7. +2 +7. Yeah, okay, now that makes sense. Left and right. So I just basically, the change I've done is instead of doing +2 here and +8 or +6 here, I just do it here before computing the screen coordinate. Then I can adjust this test. So let's try again. Okay. Seems to work. All right. Let's try to fall. And then I fall in the memory because there is no floor. All right. I think that's a good fix, actually. That's really much accurate, actually. Let's try to fall here. Cannot fall anymore in between these two. So the +6 was better. All right. Let's go back to +6. No, now I can fall. Okay. And then we have the other issue, which I think, but I'll try again, which I think is what I was talking at the beginning of the stream. The screen falling while the character is also falling. I think so. Probably that. All right. So let's first let's commit this fix. Bug fix. So let's review it. So like I said, instead of doing the +2 and +6 after the test on screen, I just move +2 here, +6 here. Call it left and right, and then I can do this double test here. And I think we don't need to worry about get pixel when it's outside of the screen, because the get pixel function is checking if it's outside of the screen, and if it is, then it returns 0, so it will return a black. I can show you. It's the get pixel. Yeah, no, I'm too lazy to show you, but I don't have it here. All right, so yeah, that's the fix. Fix the get check collision. Fix the is there collision at for when the coordinates are outside of the screen. Okay, then I think we still have time. Yeah, 1 hour. I'm streaming from 1 hour 7 minutes. I think we still have some time to try to fix the down. We can we can try. Not sure we'll succeed, but like I said, I think it's the screen moving and the main character moving also. Let's check again the static collision function. So we should normally arrive here. We are not jumping, we are falling, we are here. We check this. We check here. If not, right, because the screen is moving, then, and we are not in fall, then we just init the fall. So basically here I want to add the transition of the screen. So I will check like y plus 13 under plus oh, by the way, yes, I think this is not correct. The sprite, the rig sprite height is not correct. This is 16, I think, in the sprite data. This is the sprite data height, but not the full sprite, I think. So yeah. Yep. So that's not correct, though. We should just put plus 13. Yep, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, yeah, 13, 14, 15, plus 12, should be plus 12, I think. Right, yeah. So here, it should be plus 12. Oh, yeah. And here actually it's always plus 12. Or is it? Do we shift? I think we don't shift when we are in crawl, right? Let me check the draw function again. When we are crawling, oh yeah, we shift plus 5. Because crawling is like that, so okay. So that means normally the top should be x plus 5. Should be like that. If we are crawling, the top should be x plus 5, otherwise it's just y. And here the bottom is, if we are crawling, it's x plus y plus 1, 2, 3, 4, 5, 6, 7, 8, 8. Okay, so 0, 1, 7, I guess. Because, yeah. All right. So the bottom, if we are crawling, is y plus 7. Otherwise, if we are not, it's y plus 12. All right, and left, so like this, and left it's always x, and sorry, and right crawling x plus crawl width, and that's correct. And else, which is 9. This one is 9. Map data, sorry, spray data, which is 9. That's correct. Yeah, I think that's more correct like that. That's really the 4 coordinate of the drawn pixels, and not the sprite data that we use to store the sprite actually. All right. Let's test again like that, just to see if I break something or not. I think not, but I can try to switch the level by crawling also. Switch the screen. Okay, and if I crawl, oops, I fall. Let's try try again, slowly. Yeah. Oh. I'm not sure about the white when I'm Y when I'm crawling. But anyway. Let's try in the other direction. I'm still falling. Okay. Because yeah, I don't change. I never change the Y. Only in drawing I change it. Okay. Just for testing, I will remove this. And I think that won't change a lot. I don't know why I think I don't release the button, but it seems that the main character exit the crawl state. And it should not. Yeah, clearly the character exit the crawl state. All right. So I put back this because I think that's correct. Oh, yeah, top +5. Yep, that's right. So x +5, that's the top, then 8. Yep, should be. All right, and the bottom, no, it's not +7. That's the bug. Yeah, the bug is here because Y we'd never change it, so it's always +12, even if I'm crawling. Yep, that should be like that. Let's try again. Okay. Okay, I'm still falling in that direction, but oh. I didn't go through. That's strange. Let's try again to fall. Yeah, this one. Yeah, because I fall from less high distance. All right, so try again to crawl. Crawling to the right seems okay, but to the left I'm falling. Oh no, No, it's not okay. All right. So, but like I said, I think we still have the issue about this function that is testing here without taking in consideration the how many pixels the decals moved during the frame. And I guess we should ask the map manager for that information. So I just wanted to try that. So map manager get, how we call it, get camera transition move Y. Okay, we can try that. We'll go to map manager. Return the number of pixels that the camera moved during the frame. I think that should be camera transition Y. Let me check. During camera transition, we increase it. Yeah. So if we move positive value, then we should remove that. So I guess that should be minus. Let's try. That works, but we had some strange for one frame the character went into the ground. So we may have, yeah, it went inside the ground. Okay, so maybe that's yeah, one frame delay, but that probably could do it. So, all right, maybe we can deal with it like that. So yeah. All right, I think I will stop the stream here. First, let's commit. Nope, this one here. So what do we have? We have to fix, I think, here first. We have a more correct top and bottom. Better computation of the top and bottom sprite, visible, I will say, visible sprite of the main character. And all right, anything else here? No. Ah, yes, here was that. Yeah, and the transition. Yeah. Try to add the camera transition when checking the collision of the main character. So, like I said, you could also stop the main character, prevent the main character from falling, just like keep the character immobile on screen. And some games does it like that. When there's transition, the character freeze on the screen. But I don't like the effect. It's kind of old school actually. But why the programmers did it like that? It's because it's much easier. Normally it's easier because you don't have to, you have less risk of going through the collision. If you freeze it, okay, that just the screen is changing and then you continue to fall. I think it's less risky. Where here you are very, what I'm trying to do is to be very dynamic. So he's falling, also the wall is moving. So yeah, it's more difficult to compute the collision because it's two dynamic objects like entering into each other. So I don't know. I will try to solve that. We'll see. And then yeah, we added this function in the map manager. What did we do? We just add this function. All right. Yeah, that's it. All right. So obviously for the next stream, we will have to fix those remaining bugs. So I guess I will try to do it outside of the stream and then show you what I've changed or how I fix it. We have bugs when crawling, like transitioning left and right in crawling. We have still bug when falling. And yeah, I'll try to make sure that all the different cases is okay. And if it is, then that's a good news. That means we will have a nice transition in between screen in the different stuff. I will have also to test the ladder, so to transition from bottom to top. So I will probably add a ladder in one of the screen puzzle to go back again. And yeah, I will try probably to make a full path with ladder everywhere to go from the from one screen to the other in any screen. And yeah, if all that works, then we will have made a great progress, and probably then we will be able to fix the other items. And then after fixing the items, do the AI. We want to have the AI moving also. So thanks for watching this, and I hope now it makes more sense why we have int coordinate system for the main characters and not just char. And yeah, I already explained you that, but I guess now you clearly grasp it, why I'm doing it like that. So thanks for watching, and then I will say see you during the next stream. Bye bye.